Good morning, everybody. So my name is Alberto Bucciero, and I'm the coordinator of the Digital Heritage Innovation Laboratory in Lecce. And at the same time, I'm coordinating currently the development of the new platform called DIGILAB of the E-RIHS. But first of all, I want to thank the project that funded all the results and the achievements we made and we will make from now on, that is called H2IRS, that is the acronym for Humanities and Heritage Italian Open Science Cloud. It is a project that with the target of create cluster of federated research infrastructure that will allow researchers to share knowledge in terms of tools, of services, and above all, in terms of data. The four infrastructure are E-RIHS, that is playing in this project the leader role, and Clarion, Operas, and Daria, and this take also me the chance to thank all Daria representative and Elena, inviting me today. What is E-RIHS? E-RIHS is the European research infrastructure of heritage science that is made up of four main platforms. You may already know some of that. ATLAB provides access to the physical heritage science collections and archives. MOLAB, they are the mobile laboratories that provide instrumentation where the object is, so going all over the Europe and sometimes the world for non-invasive measurements. FixLab, they are providing medium and large scale facilities for when there are non-transportable analytical instruments. And finally, we find DIGILAB, that is providing the virtual access to scientific data. And it is currently under development. So, DIGILAB is not just a software platform. Even if I'm a software engineer, as Elena said, E-RIHS and DIGILAB will be supported by a cluster of federated data centers. At this time, they are in number of 3. One is here in Sicily, in Catania. The second one is in Naples. These two are already up and running. And the third one, the biggest one, is in Lecce and will be started hopefully in the next few weeks. So you may say that managing research data should be the main target of DIGILAB. It is true, but it is not enough, because data is not knowledge. So, turning our attention to our specific field of research, what is happening usually is that the scientific data are used just and only to achieve scientific results, but just only a moment after the publication, they got lost, because we have data within USB sticks, within virtual drives, within email attachment. This may happen for different motivations, for mentality, for lack of time, lack of suitable instruments, or issue related to scientific evaluation as well. But most of the time, we even don't know where data that led to a specific scientific results are. So, In consideration of this, I propose you three main questions. Where are the data used to find a scientific result already presented in a publication? You know where are all your data? And how did you use this data? In what sequence, what post-processing methods you used upon this data? And finally, how the data are related to each other. So, to try to answer the first question about the data storage, we may say that to avoid the losing of data, we just need a virtual drive, for example. We already have many of them, OneDrive, Google Drive, Dropbox, and in our institute we have Nextcloud. In our organization we have OnCloud. There are many virtual drives, but do we really need another virtual drive? Is DIGILAB another virtual drive? The answer is obvious, is not. But is the capability of storing and retrieving data enough for the research field? The answer is on another time, no. Because we need not only to store data, but to being able to curate data, so to adding annotation to data, that is metadata and paradata. For example, to make data findable, to make data accessible, interoperable, and reusable. So the first question, the first answer to this first question is that DIGILAB must provide the support to the data fairness principle. So giving the researcher the capability to metadata, to paradata, to find, to reuse, to access, and to interoperate with data. But the second question is how the data were used. As every research process can always be seen as a sequence of activities, in the picture there is a very high simplification of a generic process that goes from the documentation phase, where maybe we do some preliminary analysis, for example, biographic acquisition of information, to the phase of acquisition of data on the field, thanks to the activities you made yesterday, I think. Or for example, laser scanning campaign or diagnostic campaign, for example. Then another activity could be the data processing, and for example, the post-processing of the point cloud that has been generated from the laser scanning campaign, and finally to the publication. So, knowledge is not the only and final result of our scientific study. It's not our publication, but knowledge is the process itself that led from the beginning of the acquisition of data to the publication of data itself. So we have to answer the second question, how the data were used. We have to save the scientific research workflow. And the third question is how the data were related to each other. So to answer the third question, we have to recall how the concept of data, information, and knowledge are related to each other. Now, I voluntarily used the terms of data, information, and knowledge as synonyms, but they are not. Data is whatever sequence of symbols in, for example, alphanumeric symbols. Information is created when data is processed, organized, structured, and so they get some meaning. And knowledge, what is knowledge? Knowledge is what we know. But let me do a simple example. So 39.5 is data because it is just a number, a value without a meaning. If we say that 39.5 is a temperature expressed in degrees, so it became information. So we have adding a meaning to a data. If we say that 39.5 is the body temperature of someone, we could consider it a dangerous signal. So it is knowledge. But 39.5 is always a signal of danger for a human being. Maybe if it's a baby, it is not so dangerous, but if it's related to old people, it is. So it is connected to the context. So we may say that the temperature, the human being are related by some kind of semantic relation. And the human being and the concept of age are as well related. And also the danger concept is related to, in this case, to Lily, that is our human being. So we understand that knowledge can be expressed by trying to relate concept with relation, semantic relation, and this is the third great pillar on which the DIGILAB has been built. Another example of knowledge representation is the following, that is done, that has been designed within the field of environmental monitoring of cultural asset, that, by the way, is the new platform that we are developing within the H2IOS project that is called SENSE. In this case, the concept that we are trying to relate are, for example, this is a really high simplification, sensor, temperature, gauge, that is the graphic, one of the graphic representation of the physical property of temperature, widget that is a kind of representation. The Lily is our human being. Museum operator is the type of human being. What is the role of Lily within the environment? And Mona Lisa is obviously the object, the subject of this diagnostic environment. Obviously, each of these concepts is related to each other, and obviously it is not so simple, the full picture. It's much more complicated, but this just to give you an idea of what we are doing. This is only a simplified version of the schema, the logical schema that we are implementing for all the single disciplines of HS for heritage science, that will be used to map the conceptual map of each researcher doing his own scientific work. So DIGILAB will be built upon three pillars that is the answer to the three previously given questions. Data management, process management, and knowledge management. These is the three great pillars of DIGILAB. I forgot to say that we are developing the Italian node of DIGILAB, so because every country involved in E-RIHS is developing its own, and at European level we are developing the main node of DIGILAB. This is what we are doing for the Italian node. So finally, we may say that DIGILAB will give support to the data lifecycle management in terms of data acquisition, data curation, data publishing, data processing, and data use, and this is the first pillar. The second pillar is about the process, will give support to the research workflow of each researcher, giving him or her the capability to design his or her own scientific process and to start and manipulate it. And finally, the third pillar is the knowledge graph, that this platform will be able to manage knowledge as graphs in terms of graphical representation, so representing concept and semantic relation, but also in terms of technical repository. Information will be stored in a graph DB, so in a tribal store DB. So the queries that will be able to do on DIGILAB will be not simple SQL query, but will be StarQL queries. Starting from these pillars, we started a survey campaign within our institute and we found some major requirements for the DIGILAB. That is the very first question, the very first need that my colleagues asked me was, please give me some database to store my data, but not a simple database like a virtual drive. They need some simple data entry interface to be able to populate a database. So DIGILAB will give user a personal data space to store his her own structured data and metadata, mapping them against an ontology, so a knowledge graph representation of knowledge, in form of heritage digital twin. The second one is to provide simple facilities to automatically build the data input forms and the customized report to visualize, to show data. Third requirement is give access to data, digital tool and services through a visual and ergonomic interaction based on 3D knowledge graph, as previously seen. Fourth, support the design and the publication and the execution of the scientific workflows. Provide 5, the pre-configured scientific workflow to the community, and from the 6th to the end, there is some new features that we added to the previously given design of the DIGILAB, that is provide the capability of combine services, combine tool, combine workflow in order to create a new one. In this, we call this virtual research environment. This is our idea of virtual research environment. 7, allow users to collaborate in the shared workspace in order to manipulate data, services, and tools in a collaborative way. This is the collaborative virtual research environment. This idea was brought to the European level and was kept within the main feature of the digital.UE design. And finally, to allow the remote access and control to physical instruments, for example, is the case of the already mentioned Sense environment, Sense platform that allows to remote monitoring microclimate environment in a room, in an archaeological site, and so on. So the last 3 requirements are a new pillar for DIGILAB, that is the collaborative virtual environment 1. And just because we will be able to combine data, tools, and workflow, we will be able to create a new workflow starting from a set of a list of already existing one. So this collaborative virtual environment will enable researchers to create new scientific process starting from the already known one. And finally, the roadmap, as you may understand, DIGILAB is not yet finished. The project has started in April 2024, and the design phase will be ended by this December, we hope, and the end of the development to say the truth, is already started, even if in this picture it seems we are not already developing, will end by June of 2025, and by September 25, the platform will be up and running, and we will go live, and we will provide hardware and software services to all the E-RIHS and more in general to HIOSC community. So that's it. Thank you for your attention. If you have any comments, please tell me.